In this video, we're going to look at outcome 1, worksheet 1, question 1 from engineering mathematics 2. This is a trig topic. And in the first question on this worksheet, we're asked to use our trig identities for sine squared A and cos squared A. And the questions are currently on the left-hand side of the screen, and the relevant part from the formula sheet is on the right-hand side of the screen. So these are the trig identities we may be making use of, and in particular, we'll be making use of the latter two on the page. Let's work through the questions in turn, explaining how we're going to use these identities to solve the problems. So 1a asks us to remove the brackets in this expression here. 4 cos x all squared. The first thing we wish to do is to remove this bracket and address the power on the bracket. Removing the bracket and squaring, we're going to get 4 squared times cos x squared, which gives us 16, and we write out the square of cos x as cos squared x. But that's not where we want to leave this, because we want to present all of our answers in terms of cos or sine. We don't want to have any squared terms, so we can use our expression for cos squared x from the formula sheet, and we can write out 16, and this is replaced by a half times, open another bracket, 1 plus cos of 2x. So remember, when we are using this, to be careful, cos squared a is equal to a half brackets 1 plus cos 2a, close brackets. And so we can put this in, taking care to close all of the brackets. We can then multiply this through, and we can do it in one stage. 16 times a half is 8, and then we'll have 8 times the items in the brackets here, so we're going to be left with 8 plus 8. 8 cos 2x. Moving on to question B. This time we have 25 sine 4x all squared. And so we take the exact same approach as before. We're going to square the term in the brackets first. So we're going to have 25 squared times the square of sine 4x. The 25 squared is 625. And again, when we have a trigonometric term and we square it, it becomes sine squared 4x. You notice nothing happens to the 4x, it's the sine term that's being squared. And then we're going to use our trig identity again. So the 625 will now be multiplied by what the identity gives us for sine squared of a particular value. A in this case A is 6, so we can write a half 1 minus cos, and it becomes 8x. It's twice what was in the bracket after the sine squared. And you'll notice, even though it's sine, we're still getting a cos term in the identity. For both cos squared and sine squared, we're going to get an expression in terms of cos. And then we can multiply this through again as well. And we're going to end up with 312.5 minus 312.5 cos 8x. And that is the answer to part B. Moving on to C. This time we have the expression 78 cos 8x minus 1 all squared. And we observe a similar procedure to the previous two questions. We're just going to be a bit more careful with the bracket in our cost term when it comes to using the identity. 78 squared is 6,084, and we've got cos squared 8x minus 1. So we want to now use our identities once again to get rid of the cos squared term. And so we've got 6,084 brackets half times brackets 1 plus cos, and again it's double the whole bracket, so take care to multiply both terms, 16x minus 2. So 8x minus 1 times 2, 16x minus 2. And of course, half times 6,084, going to give us 3,042. And that's multiplied by 1, so 3,042, and that's also multiplied by cos 16x minus 2. We write down 3,042 cos 16x minus 2. And that is part C. Now to part D. And part D is similar to part C in the sense that in our bracket we're going to have two terms in the bracket after our trig function. So let's write this out first of all. 39 sine brackets 3x plus pi over 2. That's all squared. So as before, we can remove our bracket by squaring 39 and by squaring the sine 3x plus pi over 2 to give us 1,521 sine squared 3x plus pi over 2. And we apply the identity for sine squared. Open up a bracket, and then that can be replaced with a half times another bracket, 1 minus cos, and then it's double what's in the bracket above. So we're going to have 3x becoming 6x and pi over 2 becoming pi. Then multiplying all of that out, we're going to get 760.5 minus 760.5 cos 6x plus pi. Then moving on to questions E and F, where they're going to be a little bit of additional complication, but it's really just more algebra with a bit of a trig problem thrown in. So as long as we take our time, everything will be absolutely fine. So problem E is this one, 5 cos 2x minus 1. And to this, we've also added a 3 before squaring the bracket. Now here it's going to be slightly different. We have two terms in the bracket. We've got the 5 cos 2x minus 1, and we've got the plus 3. So we use our rules for expanding brackets in order to find this. You can either write out the same bracket twice and multiply them together, or you can use the rules for squaring brackets, which I'm about to do just now. So first of all, we'll start off with the first term squared, so the 5 cos 2x minus 1. So we need to deal with those. That's going to be 25 cos squared 2x minus 1. Then we add to this 2 times the first time, so we're going to have 2. Then we're going to have that multiplied by 5 cos 2x minus 1. And then we're going to multiply that again by 3. So 2 times the first term times the second term. And lastly to that we're going to add the square of the final term, so square of 3, so we're going to add plus 9. So we've squared the first term, we've squared the second term, and we've doubled the product being the two things multiplied together. That's our rule for expanding a square bracket. And we can deal with all of this one bit at a time. So let's deal with our 25 cos squared 2x minus 1. We're going to have 25, open our brackets up here and take in the identity for cos squared. So that's going to give us a half brackets 1 plus cos 2 times the contents of the bracket of, which is going to make it 4x minus 2. Make sure we close all of those brackets. And moving across, we had 2 times 5 cos 2x minus 1 times 3. So 2 times 3 times 5 is going to be 30. We have 30 cos 2x minus 1. And we've got a plus 9 as well. So we can now expand this last bracket here and tidy everything up. So 25 times a half is 12.5. 12.5 times 1 is 12.5. Going to have 12.5 times cos 4x minus 2, so we'll have plus 12.5 cos 4x minus 2. And there's nothing else we can do with these other terms at the moment, so we write them in as they are, cos 30 cos 2x minus 1 and plus 9. But of course, we can always gather like terms, and you can see we've got two numerical terms. We've got a 12.5 and we've got a 9, so we can combine those two, and we can write in our final line of working, we can write 21.5 plus 12.5 cos 4x minus 2 plus 30 cos 2x minus 1. And that's question E. And our final question, question F, we'll write out first and then start to solve it. We're going to have 8 sine 2 pi x plus 3 minus 7 all squared. And we expand this exactly as we did in question E. So we'll square our first term. So we'll square 8 sine 2 pi x plus 3 to get 64 sine squared 2 pi x plus 3. And rather than write it all out, I'll just say it out this time. We're going to have 2 times 8 sine 2 pi x plus 3 times minus 7. So rather than write all these out. So 2 times 8 is 16, and 16 times minus 7 is minus 112. So we're going to have minus 112 sine 2 pi x plus 3. So what that term is there is the two terms in the brackets multiplied together and then multiplied by 2. And at the end, we add on minus 7 squared. Minus 7 squared is positive 49. So in the next line, we just have to deal with our sine squared identity. We'll have 64, then we'll have a half, brackets 1 minus cos, and we double what was in the bracket from sine squared. So we're going to have 4 pi x plus 6. And all the other terms are still here, the 112, negative 112 sine 2 pi x plus 3, and our plus 49. Our bracket on the left-hand side, 64 times a half is 32. So we'll have 32 times 1, and 32 times minus cos 4 pi x plus 6. And we'll have the rest of the terms. I'll write them in here. Our second last line of working. And then we can combine the numeric terms again, the 32 and the 49, to give us 71. No, 81. And that gives us our final answer, 81 minus 32 cos 4 pi x plus 6 minus 112 sine 2 pi x plus 3. And that concludes all of question 1 from outcome 1, worksheet 1.